Okay, in addition to what we have with types of linear equations, okay, we have also in the realm of nonlinear equations, we have what are regarded as X and Y-intercepts. Now we have for the determination of X and Y-intercepts, okay, again, keep in mind that all points are of the form xy in the xy coordinate system. And in terms of the determination of each type of intercept, we have for the x-intercept, we have the general coordinates x, 0. And by definition, the x-intercept is the location where the graph touches or crosses the x-axis. And in terms of what we have in the procedure, okay, we have labeled in blue. Okay, we're looking at, say, in each equation that contains both x and y, okay, we are to set y equal to 0 and then solve for x. And in terms of the y-intercept, okay, again, the general coordinates are going to be 0, y, and the y-intercept will be the location where the graph touches or crosses the y-axis. And we have in an equation, okay, we set x to 0 and solve for y. And let's say that if we have, as a case of the determination of both intercepts, okay, we have for the linear equation, which we have at 10x plus 12y equal to 60, if I determine the x-intercept, again, for each x-intercept, I set y equal to 0 and solve for x. So we have in the setup, okay, so again, y is that which will be set to 0, and I'm going to be solving for x. So we have in the rewrite, okay, we're going to have 10x plus 12 times 0 is equal to 60. And 12 times 0 is 0, so the left-hand side becomes 10x. So I have that 10x is equal to 60. And we have upon division by 10, okay, we'll have left-hand side becomes x. And we have with 60 divided by 10, okay, this will become 6. So we have the x is equal to 6. So we have for the missing coordinate, we have it 6. So we're going to have an x-intercept, and the location will be on the x-axis at 6, 0. So again, we have our x-intercept. Okay, we have at 6, 0. Now, in the case of the y-intercept, okay, we're going to be looking at setting x to 0 and solving for y. So we have upon setting x to 0, okay, left-hand side is ultimately going to be just 12y. And so we have in the setup, we have 12y is equal to 60. And solving for y, we have with division by 12. Okay, we'll end up at y equal to 5. And so the value 5, okay, this will signify what the y value of the y-intercept is going to be. And so we have for the y-intercept, okay, we have on the y-axis at y equal to 5. So we have with our y-intercept in coordinate fashion, we have at 0, 5. Okay. And just for what we have in the illustration, okay, so we have with the graph of the equation, 10x plus 12y is equal to 60. So we're going to have the x-intercept located at 6, 0. And we have the y-intercept, okay, located at 0, 5. And again, we have for this line, this represents all the combinations of the values of x and y such that 10x plus 12y is equal to 60. Now, again, x and y-intercepts are not just confined to linear equations. And we have as a case here. Now, we have an equation that is second order in both x and y. Now we have, for this equation, we have 4x squared plus 9y squared is equal to 36. And in terms of the determination of each intercept, okay, for the x-intercepts, we're solving for x. And again, y is going to be set to 0. And so we have, in the rewrite, in case you have 4x squared, we have plus 9 times the square of 0. So that is going to be negligible. And so we have 4x squared is equal to 36. And looking at solving for x, okay, so if I divide both sides by 4, so we have the x squared is equal to 9. And we can revert back to the square root property of equality. So if we have x squared equal to a constant, we can go from second to first order and say that x is equal to plus or minus, okay, the square root of 9. So there will be a couple of values that we have for x. We're going to have at negative and positive 3. Okay, and we're going to get back to that. So we're going to have a couple of x-intercepts, one at x equals negative 3, the other at x equals 3. Now we have for the y-intercepts, okay, now we have in this one, again, we have solving for y as x is set to 0. So you have 4 times the square of 0 plus 9y squared is equal to 36. Okay, so we have left-hand side of the equation becomes 9y squared is equal to 36. And we have upon dividing by 9, we're going to have y squared is equal to 4. And for what we have in y, in this case y squared, we can reapply the square root property of equality. So in this case we have y is equal to plus or minus, okay, the square root of 4. And from this we're going to have y equal to both 2 and negative 2. And so just taking what we have for x, for the determination of the x-intercepts, so we have 2 intercepts on the x-axis, one of which is going to be negative 3, 0, and the other which we're going to have at positive 3, 0. As for the y-intercepts, again we have 2 values in y, so just as we have 2 x-intercepts, we will have likewise with the y-intercepts, and we have for those locations, we will have it 0, 2, and also at 0, negative 2. And we have just for the graph itself. All right, so as you look at the graph of 4x squared plus 9y squared is equal to 36, we're going to have the figure to be an ellipse. And once again, we're going to have for the intercepts, and we have for the x-intercepts, we have negative 3, 0 and positive 3, 0. Again, both points are on the x-axis. And for the y-intercepts, we have 0, 2 and 0, negative 2.